Dear participants, so welcome you all of you for the Atal sponsored 6 days online FDP on next generation medical automation, the role of AI and IOMT in transforming healthcare system for day 3, session 5. Welcome you all. Bhaskar?
Yes, a very good evening to and all. And as we already discussed, for each and every session, we have a group photo part. So all the participants are requested to turn on the camera for a group photo session. Dear participants, I repeat, all the participants are requested to turn on the camera. As per Atal instruction, the group photo session is mandatory. So all the participants are requested to turn on the camera. Thank you, dear professors. You may turn off the camera. A very good evening to honored gathered here. It's my immense pleasure to welcome you all for this day 3 of Atal's sponsored 6 days online faculty development program on next generation medical automation, the role of AI and IOMT in transforming healthcare systems. Welcome you all. It's my honor to welcome our today's chief guest, Dr. R. Murugan, Assistant Professor, Department of EC, NIT, Silchar, Assam. Welcome you, sir. Before letting into the session, we may see the short intro about our resource person. Dr. R. Murugan is currently working as an assistant professor, Department of Electronics and Communication Engineering, National Institute of Technology, Silchar, Assam. His academic activities include he completed his Bachelor of Engineering in the discipline of Electronics and Communication Engineering from Anna University at 2005 and completed his master's degree in the domain of Embedded System Technologies from Anna University at 2010 and completed his doctoral degree in the stream of Information Communication Engineering from Anna University at 2017. He has more than 10 plus years of experiences in teaching as well as in the projects. He has received more than 1.5 crores of funds in various research projects, and as well as he has a granted patents of number of 4 and also published more than 60 plus journal articles, 2 books and 12 book chapters and 65 conference proceedings. He is a recognized PhD supervisor at NIT Silchar, and under his guidance, 3 scholars have completed the PhD and 8 scholars are doing their PhD. He acted as a chairperson, delivered special lectures in various conferences, seminars, and workshops. He also organized 30 plus workshops, faculty development program, and conferences. He delivered a special lectures in various universities in the stream of AI in medical image processing, data science, computer-aided diagnosis of medical images, and deep learning. He achieved more rewards, and which includes awarded international travel grant by ANRF for presenting the paper at the IEEE conference in Malaysia. Also received a Best Use of Technology Award in Biodesign Hackathon. So indexed a researcher awarded by the World Health Organization. Also received a Young Researcher Fellowship from DST Serve and received an Outstanding Reviewer Award from Elsevier Journal, as well as received the Best Paper Award in the International Conference presentations. His research interest includes medical image processing, machine learning, deep learning, retinal image analysis, computer vision, pattern recognition, Internet of Medical Things, multimedia comprehension techniques. This way, I wish to welcome our resource person, Dr. R. Murugan, who is going to handle the session on the topic of AI in medical imaging and diagnosis. Please, sir.
Yeah, thank you very much for the nice introduction. Hope I am audible to you.
Yes, sir, it's audible.
Okay, thank you. Is my screen is visible?
Yes, sir, it's visible.
Yeah, thank you. Again, good evening to one and all present here. Today, the topic which we are going to present in this seminar is AI in medical imaging and diagnosis. Let me describe the today topic so that the audience like you will be benefited what type of imaging which we are going to present today. If you look at the term medical imaging, it is a generic name, right? So the medical imaging, which include multiple modalities, like if you look at, for an example, X-ray imaging, CT imaging, MRI imaging, like we have a number of medical imaging. So being a researcher or being a scholar, to work with any one medical imaging, like, we have to select first, then of course, which we need to, progress in terms of the research with the medical imaging modality, what we have been selected. And of course, what we are going to do with this medical image. So generally, clinicians, medical practitioners can, work and play with medical images. And what is the role of the technologist like us and engineers, work with medical images? What we actually going to do? So it's a layman, like the medical practitioners, based on their practice, they can able to diagnose the image. But being a technologist like us, we do not have any experience to directly like getting into diagnosis, but rather we can use the technology like for automatic diagnosis. So what technology which will the whole the research world, the industrial world, like the emerging is like AI. So of course, with the help of AI, the technologist, we are going to diagnosis in a medical image, any medical image, which we can say. This is the description of the whole topic, which we can see. In this particular concern, if you consider a medical image, like it is a generic name. But, like in the last, 10 to 15 years, I have been working with multiple medical images. But today I have been presenting one of the medical image, which is called a retinal image. So what is this retinal image, and why we have selected this retinal as a part of the discussions? We have a long description which we need to discuss. Everybody knows the retina is a part of our human eye. So in the retina, like in most of the eye diseases, the symptoms are occurred in first, or we can say the initial symptoms of any eye that has to be, generated in the retinal lesions. So like we have n number of eye diseases which we know to us. Let's say, for example, the glaucoma, is one of the dangerous eye disease we may heard about in many places. And also we have been heard about cataract is also another disease, like diabetic retinopathy is also another retinal disease. So like we have different 62 different types of eye diseases which are available. So which one among the eye disease, which is called a retinal detachment? The word is, very crucial name to understand. Detachment. And also from this word, we can understand the literal meaning of the detachment is the retina is generally going to detached from the original position from the eye. Right? So the whole talk will deliver you a study of retinal detachment. So we are working with this particular disease, the retinal detachment, in the last almost 6 years which we are working. And we have been used multiple AI algorithms. It's not only a generic AI algorithm. We have been working with the machine learning algorithms, deep learning algorithms, and also we are working with the graph neural network algorithms. So we have so many algorithms which we have been working for the diagnosis of this retinal detachment. And the whole journey of the 6 years, which I'm going to quickly share with you in the next 1 hour. So this is the description of the whole topic of our discussion today. Let me start with a simple understanding about the retinal detachment. What do you mean by retinal detachment? The retinal detachment is nothing but it is an eye disease. The nature of the disease is that the retina, which will be detached from their original position. What is that positions, how it is detached? If you look at the anatomy of the human eye, which have been given in the slide, initially the retina, which will be located, the backside membrane of the eye. But what happened due to the effect of this disease, the retina is actually relocated. You can see the layer, the outermost layer of the eye, which used to call optic nerve head. Now it has been actually detached, changed from their original position. This, the condition which we used to call retinal detachment, right? So this is the eye disease. So why it is happened, how it is happened, that will be discussed further, but which we need to understand what is retinal detachment. Now, the retina is detached from their original position. So what is the effect once it is happened, the retina is detached, then what will happen? Of course, the visual impairment, the particular person will gradually lose their vision if it is not treated timely. Okay, so in this case, the detachment is, very, very emerging kind of eye disease. Even like most of the developing countries also, they have a lot of statistics. The number of patients are keep on, increasing with this, the medical condition. Why it is happen and what is the first symptoms of this particular disease? If you look at, I have given 3 pictures in the bottom of the slide. Like there are multiple symptoms which we can able to came to know once the disease is occurred. But still some of the symptoms which we have been given in this slide. So for example, the first one which you should look at, there are floaters, like, the red, yellow color pouches that has to be, created if you look at any of the object. This is one symptoms which we can see if the numbers are getting more, and of course, your eye is in the not in the normal condition, it is in the abnormal condition. So that you require immediate attention. This is one kind of symptoms. And if you look at the second one, which you can see here, the half of the vision is getting blurred, which you can see here. Because the reason is that the retina is detached. So the remaining portion, you will not get the proper vision. Okay, this is also it's also a symptoms which you'll consider, but it is an extreme case of the detachment, we can say. And the third one, which I have been given, a lot of floaters, like you can see here. Generally, if you're not properly sleeping or slept in the night, you will get these floaters. But still, the numbers are more if the eye is abnormal. And apart from that, what else? What the causes, like the particular person, which leads to this retinal detachment? Like, of course, the many conditions which include like blood pressures, that is also considered one of the cause, and also the extreme, the diabetic level, diabetes mellitus. Right? So it is also another cause of the disease, and also the main thing is that proper the sleep and the improper sleep, and also pressure, stress, which will many symptoms like the causes that we can able to define it. So this is what the we can able to understand what is detachment, what is the symptoms of this one, and how it is occurred. Right? A very short, the biomedical perspective of this disease, retinal detachment. Okay, now coming to the statistics, why need a special attention to this disease? Like, since it is a the eye disease, and most of them, many of them don't heard about this disease. Like we know very common eye disease, but many the special. If you want to do any research, if you have a special attention, then only you can came to know this particular detachment disease. Why and what we can do, why it is important, and what the technologies we can do with the disease. If you look at the statistics, I have given some countries, even the developed countries like US, Netherlands, and the annual incidence is also much higher than for a 1 lakh person. The percentage is from almost 18%, and it leads to 20%. And if you look at the another, some set of countries, England, Denmark, Taiwan, that is also, we have a large percentage, 15 to 16 percentage. And also in Asian countries like China, Singapore, even 18. And if you look at the developing countries like India, the cases are almost around 18% of case. Like, if you look at, even in the 1 lakh, the percentage is 18, and in the whole, the populations, the numbers are more. That's why we required a special medical attention for this particular disease. And most importantly, in almost in all the countries, the aged people are getting affected by this disease. If you look at the age range, is from 55 to 70 years almost. So, once we are reaching into the 50, 55, our human body biologically will get a lot of, the impact, and those impact actually creating, the abnormal symptoms to this particular disease. Right. So that's why, we have to take it to special attention for this particular disease. It's not just like, the cataract, glaucoma, and all. Like, this is a very dangerous disease. The problem is that if it is a glaucoma, there are the white color bulb that will be creating in the eye, right? So if you apply a laser treatment, then it will be completely cured, the cataract. But if you look at this disease, it's very dangerous. The retina is actually relocated from the original position, right? So that is, a very, very dangerous eye disease, which we can say. Right. This slides maybe given you more insights into the retinal detachment. What are the different types of retinal detachment? If you look at the detachment cases, if you look at the first image, it is the normal image, the first one, which you can say the normal one, because there is no abnormal symptoms actually, which you can able to see this particular first image. This image was captured through fundus camera, which will be available in almost in all the eye hospitals, which you can see here. That's we used to call this as a fundus image, retinal fundus image. And this is one of the two-dimensional image, and most of the researchers, those who want to work, or most of the clinicians which want to screen any eye disease, they will acquire this two-dimensional image from the fundus camera, then they will taken for the screening. So like the whole study, we have also, consider the retinal fundus image for the detection of the diagnosis of the retinal detachment. And the whole detachment, which we can see, there are three types of retinal detachments are available. One which we can see here, the rheumatoneous retinal detachment. What is this rheumatoneous retinal detachment, which you can see here? The rheumatoneous is a very, very common, the retinal detachment, which you can simply call it as RD. And it is a early RD also. The first symptoms of this RD, which occurred in this type, rheumatoneous, right? So which is called RRD in simple acronym. If you look at the RRD, small lesions that actually created near the boundaries of the red optic nerve head. And this is like one of the treatable stages, we can say. And what happened when it will lead to the other type of retinal detachment, which you can call it as the tractional retinal detachment, TRD. So the tractional, sorry, this is not TRD, this D is the DRD. So this is TRD, right? You can see here the most of the portions of the retina, which will be covered by the the whole lesions, and also many patches, white color patches. So that will actually impact our vision. And this one, which you can see, it's called ERD, exudative retinal detachment. The whole portion, it is the extreme case. You can see here, the whole portion will lose their vision. Okay, lose their vision. So this is the nature of the whole retinal detachment disease, and also the different types of the detachment. Why I'm explaining this biological background of this retinal detachment is that once you understand this imaging background, then only you can able to do some of the technological innovations in this. So in this case, so first we need to understand the whole biological physics of this imaging modality. Yes, we have understand different types of retinal detachment and what we are going to do and why we need to discuss all this, the three types of retinal detachment into very deep. The understanding is that, to diagnose this retinal detachment is one of the huge tasks for the medical practitioner, because the reason is that the symptoms, like what it is you have been seen in the last slide, it is totally, confusing for the retinal, experts, the ophthalmologists, like eye doctors. And, so the only trained or the experienced ophthalmologist only can, categorize which type of detachment. And whether it is the detachment or some other eye disease, that is also a major challenge that will be facing by the clinicians. That is why, manual diagnosis is, like a lot of challenges that will lead to automatic diagnosis. So if you look at the manual diagnosis, there are a lot of problems, like, it is a time consuming task, which require a lot of time, and we required many the clinicians and also the supporting staffs, labor insensitive. And of course, it is very difficult in a large scale clinical application. Suppose we have, large patients. For dealing all these patients with short span of time, it is also very difficult. And also the severity level, what severity level, which we can understanding the severity level is also difficult, and it is totally complicated. So that, which will lead to an automatic detection of this particular disease. So if you look at this case, like, all this, the motivations which we actually, like progressing, or which we are uh, contributing towards this retinal detachment disease. If you look at, in 2020, when I was started working this particular retinal detachment disease, there is no publicly available data set. Since if you are the, working with any AI tool, we require a huge amount of data. But if you look at, in the open perspective, there is no publicly available data, which you can directly take and download it, you can work and we can contribute. Like, we do not have any such data set which is available. So that we have thought of, creating a data set is our first thought. So that we have collaborated with 4 major hospitals in India, and all these hospitals are, supplied a large number of images, retinal detachment images, and we have actually created our own data set, which is called retinal detachment data set, which is also available in IEEE data board, the screenshot which I have been given. So you can also nowadays you can also download this data set. You can work with any of the AI algorithms. So this is our first contribution from this retinal detachment disease. And of course, which we have been closely working with all these 4 hospitals, doctors, and the medical staffs to come up, to publish this data set. Okay, now the point of the discussion is that we have a data set. Like, we have our own data set. Then what we can do with this data set? Of course, which we need to play with many artificial intelligence frameworks. So in this case, what we have been done, the initial part of the work, when in 2020, which we have been created this data set, at that time, we have only, the binary class of the data, some set of normal images and some set of abnormal images, and most importantly, the homogeneous retinal detachment disease that we have getting from the hospitals. When day comes and we have collected even, the exudative tractional also, but in the initial time frame, we have been working with the binary images, and the later part, we have been working with multiple images, multi-class images that will also showcase some of the outcome from this talk. If you look at this, the diagnosis part, we have generated training images, which we can say the RD and healthy. And if you look at the data set, the perspective of, how we are classifying. So based on the nature of the image, where we are getting, because the image which you are getting from different sources, right? One is from North India and another 2 are from South India and one is from Northeast. There are different sources of, the places. So here, to make it into the uniform, like, we need to play some kind of pre-processing mechanism. And we have done the pre-processing mechanism like resizing and normalization. Then we have make it, the ready data set that has to be trained for the network. So here what happens is that in this particular case, of course, we have used a typical convolutional neural networks. And the training of this, the whole network from the data, which we have been done with the representation learning. What do you mean by representation learning? So how it will be differ from the normal learning? If you look at the raw data, which you can call any of the architecture, like a pre-trained architecture or any maybe a tailor-made convolutional architecture, that will be directly taken from the raw data that will be extracting the whole, the features. Then finally it will be testing. So here what happened that the representation learning itself given a lot of impact because in our initial days, the number of images are very less, but deep neural networks are data hungry network. It required a huge network images. Then only we'll get the best performance metrics. But in this case, what happens? So we have, for avoiding such, the complexity of, to get the best performance metrics, we have tried many, the mechanisms like, transfer learning, representation learning, different kind of learning mechanisms. But for this work, the representation learning is performing better, so that we have been taken into the account of training the whole data set. Then what happened once the data, the whole detailed layer architecture, which I have been given in this flow diagram, then finally we are, trained the image. Then once the image is trained, then we have tested with the whole trained one for to classify either from RD or the normal class. So in this way, like we have made a very simple tailor-made architecture for classifying the data, two-class data. If you look at, if you want to, reproduce it, maybe such architecture, maybe for not retinal detachment, but also for your work or maybe some other imaging modality, so that, the layered architecture will help you, like, to how to reproduce such type of algorithms, architecture that you can take into the reference from this table. And also, if you look at the training mechanisms and the loss, which we are getting. Ultimately, the train and the curve is going to upper. The problem like when the number of layers and the number of it will be starting from the beginning, then have some kind of loss. But later, once the network is start, fine tuning, then it will go for a better metric in terms of the whole number of layers. So that which we can observe from the two graph which have been given from the slides. Now, if you look at, since which we have been developed a very simple customized network, which is called RL-RDNet in this work. At the same time, for, to do this, all this comparison and other kind of analysis, we have done the training of the other network also, like GoogleDNet, Inception, ResNet, some of the pre-trained networks which we have been done. And of course, in all cases, the performance is better than the others. And in terms of computational time, the computational complexity also, the network is, better than the others. So that is the whole contribution of this particular network. And most importantly, as I told, like we use the representation learning in this architecture. And the same way, if you use the transfer learning, what is the performance, it is varying. Like that also, which we have been compared for this particular study. And mostly in all cases, the representation learning is given a better one. At the same time, if you look at the classification metric, and since it is a classification problem, if you look at the confusion matrix and ROC curve, all are, better than the others. So that way, like this architecture is maybe a unique for this particular data set. So that is our first, the initial contribution in this retinal detachment disease. When the days comes, like, we are also exploring more data and we are getting large data from different sources. And we have a strong research group to work with, to study the different performance measures of, the deep neural network, especially for classification of the RD disease. In this way, what happened, what we have done, so we have investigated three fundamental methods. In method one, what we have done, we have selected different deep neural network and most of them all are pre-trained network in this case. And how the performance which we can obtain. So we just done a performance analysis in one method. And second is that whenever we are doing the performance analysis, so the whole part which we can done with only the raw image, we can't, we didn't done any kind of, the pre-processing mechanisms, how we can, evaluate the whole data. So that way, what we have done, we have also done different pre-processing strategies. Which pre-processing, because in image processing, if you look at, there are multiple pre-processing mechanisms we can say. But in this case, like, what are the, the better pre-processing strategies that we can able to utilize to evaluate the deep architecture, that also we have done in the method 2. And method 3 will also we have investigated, in most of the cases which you are working with, many deep learning algorithm. And if you look at why can't you hybridize this model, right? So that also we have investigated. Like, we have used a typical modified VGG19. That's a pre-trained network. We have also used BiLSTM, and the whole combination we have done the hybridized network for the RT classification. Okay, so this way the whole, the upcoming slides will give you the more insights into how we actually investigated this whole study in different mechanisms. And if you look at the method 1, like, the very simple performance analysis, right? Like, we have utilized many deep architectures, many pre-trained networks, including AlexNet, Inception, many network, like say GoogleNet, VGG19, DenseNet, ResNet 50 and all. And we have here what we have been done. Initial, as I said, the data set is very low. So we have used the transfer learning to get the better outcome. And once the network is trained, then we are trying to classify with RD and non-RD classes. And here, if you look at the whole, the pre-trained network, so we want to, intentionally, like, find which pre-trained network is given good results for the study. So we have done a lot of analysis in this, but finally we have got in some, very good performance for the ResNet 50 architecture. Why this ResNet 50 architecture is given very good results than others? We have done many other network also, but here we have reported only the best metric what we have been obtained. So those networks are actually reporting in this table. And if you look at almost the performance, the 97, 98, and finally it is deviating from 98 to 99. Since in medical imaging, achieving 1% of accuracy is also a very important, milestone, which we can say. So in this case, like the ResNet 50 is obtained a better metric. And if you find the reason why the ResNet 50 is obtained, reasons are many, like, it is a 50-layer architecture. We have a different convolutional layer and polling layers, the whole thing. And ResNet 50 is having a capable of, extracting a deep features, in any of the data. So the nature of the network is like that. So that way, which you can see, the ResNet 50 is given a good amount of result in this case. And the same way we have done what happened in 2020, whenever we have started this work. At the same time, the people, like, in other countries, like most of them are from, China and Taiwan, they're also actually working with this particular retinal detachment. And they have a different set of images. And also we have also compared in those case times, and which one is better, which one, like, the model is given those things. And in all this case, like, we have, like, somehow proved the efficient of this whole performance analysis. And if you look at the same way, we need to discuss with the different confusion matrix and ROC curve to prove the efficient of the classification model. And in that way, like, the ResNet 50 is performing better than the others. In this understanding, what we have done in the performance analysis case, we have taken only the raw data without any, the pre-processing mechanism that have been done. Then we have a very curiosity, especially we have plenty of pre-processing mechanisms, right? And those pre-processing mechanisms, what happens is that, which will be helpful in some cases, to fine tune the model and of course to get to yield the more performance metrics. In those cases, we have tried. But in this case, we have plenty of pre-processing mechanisms which have been tried, but out of which very few which we have been listed here. And these pre-processing mechanism will helpful for the effective feature extraction from the data set. And if you look at the name of the data, pre-processing mechanisms are very common to you, even adaptive histogram equalization, then conversion of RGB to HSV, green channel extraction, red channel extraction, so many, the extractions we have tried, but, these two are fundamentally most important, especially based on the nature of the image. And finally, all these will put into the combination of this network, Inception and ResNet V2 version. And this network is predominantly working well. Then, of course, the metric is also a very acceptable range, which we can say. And if you look at, some of the, the pre-processing mechanism, suppose once the input image is like this, then if you apply the different pre-processing strategies, then what happens? You can also understand the imaging background from this second figure. And now, if you look at the whole, again, coming into the performance evaluation, and if you look at the different, state-of-the-art technique, all type of, the analysis which we have been done in different cases. Yes. So this network is pretty good, which we can say. This network, what happens is that, we have hybridized this network. How we have been hybridized? So the center portion of this image, which you can say, this one is the deep network here, which we have been used. And here we have, once the network is, completely extracted a feature, and we have used the BiLSTM model, especially, the nature of the BiLSTM architecture. The nature of this BiLSTM architecture is that, is a recurrent neural network. So most of the, the past features that we also consider into the account. So in that way, we can able to get a good metric in this case. So overall, this network also has applied some kind of pre-processing strategies and augmentation to get more input image in this case. So in that way, if you look at the whole network, this is very unique. And also we have used the different, the wavelet packet and fine tuning mechanisms in between in the part of training and also feature extraction. So this whole network, which will be given us a very good attention to classify this disease. If you look at the table, again, it will help you to reproduce this work, the whole layered architecture which have been given. And also it's a very basic structure of BiLSTM, which will be different from LSTM, because how the BiLSTM, which will be very in terms of forward layer and also backward layer in most of the cases, which you can see. So in this case, the result is also much better than the others. So you can see in terms of both numerical result as well as the quantitative, qualitative results in the form of confusion matrix and ROC curve. Okay, so one set of study which we have been done with the different performance measures of this. And in other way, what we have been done is that So when we are developing a deep network, so all this network, whenever you are going to train the model, we have used the manual hyperparameter tuning. Because in machine learning or any AI, the hyperparameter, selection of hyperparameter is more important. That will be, helpful to get more outcome of your network. So in which we have been done all the preliminary works. So we have manually selected the hyperparameter based on the trial and error, or maybe based on our experience. Then what happened when the time to think, like, why can't you use automatic hyperparameter tuning and instead of manual? That will also given a good impact, especially to train the network. So in this case, what we have been done, we have studied, there are two different hyperparameter mechanism. One is the gray wolf optimization algorithm, which we have been tried, especially for hyperparameter tuning. And also not, if you look at the gray wolf optimization, we have a plenty of, the optimizations algorithm, which are available, the swarm intelligence algorithm, the whole family. And also we have tried the soft computing constituent, like, the genetic algorithm also we have tried in this study, how the genetic algorithm maybe we can utilize for the hyperparameter tuning. So, well, taken into the multiple literature and many literature, then finally we came to get a better metric for this type of hyperparameter mechanism. So that we have actually tried in this. If you look at this particular workflow, where we actually done this hyperparameter tuning part, like we have a typical CNN architecture here that we have been developed, and we have a data ready. And here in the convolutional neural network, whenever we are going to train the network, we actually using all this, the hyperparameter like number of epoch, initial learning rate, final learning rate, all this R2 or regularization function, momentum, multiple functions that will actually doing in manual. But here what happens is that instead of selecting the manual hyperparameter, here we have used the gray wolf optimization algorithm, GWO, for selecting the best metric of this network. What happened? The advantage is that sometimes what happened, if you are selecting the number of epoch is 50, right? Then what happened? The whole system, the whole architecture, it will train the network for the 50 epoch. But sometimes maybe the network may be given best metric even 20th epoch. Who knows, right? Then unnecessarily the network 30 epoch is running, right? So here what happened? The GW will optimize which one may be the better. So in that way, we can get the best performance even last short span of time. So in that way, we can reduce the computational time. Okay, so that is the advantage of this particular architecture which we have made. And also we have studied multiple evaluation parameter, if it is how the GWO is performing better than the other swarm intelligence algorithm, PSO and whale optimizations and other. So that also we have studied. So that, predominantly the GWO is performing better in this case. At the same time, if you look at the different results, especially to prove efficient of this model, that also we have done, like if it is optimized, what will happen? If it is non-optimized, what will happen? And the whole classification metric that we have been done. So in all cases, this one, the GW is performing better than that. And if you look at this table, initially the number of contributors are very, very less. But now if you look at, the people are actually increasing, like, to work with retinal detachment. Like, but if you look at in the Indian scenario, our research group is actually first effectively contributed in this retinal detachment, especially in the Indian framework. If you look at in all cases, we are producing a better results. And as I said, not only for the swarm-based algorithm, which we can also use with the soft computing constituents. If you use a genetic algorithm, how we can effectively, higher tuning the hyperparameter that we have studied in this architecture. And apart from that, not a very simple classifications, but here we have used only the deep network, only for the feature extraction, not for classification. So instead of that, we can use a dedicated deep neural network only for feature extraction, so that the complete features can extract. Then what happened for classification, we have used the other algorithm, which we can say RVFL classifier, ELM, extreme learning machine classifiers, that we have been hybridized here. Then finally, we have taken the majority voting, then we are achieving the classification. So in that way, what happened? We are given the less computation for the deep neural network to extract the complete feature. So in that way, also possibly we can able to increase the classification accuracy in this case. So this network is also a very unique network, which we named this network is called OptiNet. Okay, this is also available publicly. You can try with this network. Suppose if you have a different data set, maybe for some different disease, different modality, you can also try these networks. So this is the whole workflow of this one, so how augmentation is done, pre-processing has been done in between those things, and how we have actually hybridized this classification, extreme learning machine, and random vector functional link classifier, all the mathematical background which I have been given. So you can refer it later on, how this can be utilized for your work. And the same way, we have tried many performance-based studies, and it's right from, it's a soft computing constituent. So we have used a different activation function, because the selection of activation function is also a major thread in challenge in this one. So that way we have studied the result with the different activation function, and also we have done the analysis with different optimizers. So ADAM, SDGM, stochastic gradient descent, and RMS Pro, different optimizers which are also we have studied. Okay, so this is one part of study which we can say. Instead of initially we have done performance-based study, then we migrated into hyperparameter tuning-based study for this. Here, the third part of the discussions comes to is that all these, whenever which we are doing in the simulation part or in the the deep neural network part, so all are giving very good results, which you can see. But here the problem comes is that whenever which we are developing a medical imaging algorithm, that finally it will lead to into the market, right? So which we need to develop a hardware. So the hardware will be going to serve in any of the hospitals. So the clinicians has to start using these trials. So in that case, what happens is that all these networks are very bulky network. And when you are going for the real time or the telemedicine applications, it's very complex to get the decision in a short span of time. So that way, to get, in this motivation, we are trying to use the lightweight convolutional neural network, especially for retinal detachment grading. Main applications to develop a prototype and hardware, and especially for the use of telemedicine applications. So in that way, what happened? So we have developed two lightweight network. The initial part of the study, which we have been developed, light RDNet, RD LightNet. This is for the two class which we have been developed. We just want to try the output. And the second method, which we have named Light MGNet, this is for a multi-class. the 4 class class which we study, which have been done. And these lightweight networks are, pretty good. And of course, this will help us to make a prototype further. If you look at this one, the lightweight network, the 2 class classification, if you look at the whole metric, it will be very, very good, and in terms of this classification. And moreover, when we actually want to develop a lightweight network, we want to, compare our result with a very popular lightweight network, which is called mobile net, right? V2, V3 also there, mobile net, which are also compared with mobile net. But in this case, the results are pretty good. And if you look at the whole, the study performance and everything, in this case, our network is better in the lightweight. And the second one is that, as I told you, the light MGNet, it is a multi-class network. Okay, so this multi-class network is also a unique architecture. So what we have actually learned from the whole performance study before, that actually will import or integrate in this particular model. So in some study which we have been done the pre-processing strategies, and here we have used some sort of very good pre-processing strategy to get the best lightweight network. And in that way, in the typical network, which will also use the hyperparameter tuning, gray wolf optimization also, which we have been used to get the the better hyperparameter. Then finally, which you can see here, this particular network will address a 4-class problem, start from the normal and tractional, exudative, and remoteness, all these cases. And this architecture will also pretty good. And this is also the first multi-class classification work which have been published in the whole research framework. And it is published in the Nature Scientific Report, which you can also refer this paper if you want to take it further. And this case, we have also used some different online data set. If you look at when we have started 2020, we do not have any publicly available data. And now what happened, people are working, and like us, the many people are actually contributing the data publicly. So in that way, this, we have also tried with other publicly available data set, retinal image bank, cataract image data, Kaggle, some different sources also. And, if you look at the whole, different optimization analysis and different classification analysis which have been supplied to prove the efficient of this model. Okay, so now what happens is that, as I told you, like, the deep network will be given, the very higher end network, like a high network, it can helpful for the prototype development. Then we are intentionally, like, we have developed a lightweight network, especially for the prototype development. But what happens is that now the deep learning technologies are actually slowly outdating. Like, now the new technology actually coming into the picture, especially for the medical diagnosis. Which one among is very popular, the AI technology, which you can call graph neural network. We used to call GNN. And also, which you can see here, XAI, that's also a popular technology, explainable artificial intelligence. And also, which you can see the generative, AI, Gen AI, that is also another popular technology, which, parallelly also, the developing that technology can also utilized for this type of diagnosis. And, most recently, the quantum algorithms, the quantum technology is also actually, developing a very fast. We can also use to, all these computational complexity issues that we can address with the quantum mechanisms. So like different technologies also are growing, like. But now it is coming into integrate this one, like especially for hardware development. And when we use the deep network, we have tried and implemented, but we have succeeded. But the problem comes into that the timing. The hardware is taking a lot of time to get into the decision. So we have intentionally again motivated how we have to get this, the decision in a fraction of time. So then we have depend with the other technology in AI, which is called graph neural network. So what happens is that in the graph neural network, and here we have tried with the same way how the graph will be helpful to extract the feature in binary class, in multi-class, all these things which you have been done. So finally, we have integrated, especially if you look at data, and here extract the features like properties. The whole graph set which from the methodology is given as we can able to do. We have for the multi-class, which you can say this graph neural network. Let me come from the problem comes into the initial the graph neural network, like conversion of image. So then what happens is that complexity, the input image, and finally this to encoding. Then finally this will help the another few samples. So this is the initial mechanism. So all these mathematical barriers later on, all these the possible extracted from the network that the even for a fraction of seconds. So and the other advantage is that required huge amount of data because neural network it will perform that way. What happen will help to hear a lot of things. The current GNN model studies also we network like say graph sage. This network is that even the binary percentage is actually the loss. 9 so that we can go for the hardware. In this case, you can have a quick glance of also that mobile app will helpful for the, you can see here whether it is a detached one or then not only a real time and this architecture. One which we can use only a metric. We have also used some other network which is called given a ensemble network. Ensemble network is coming, multiple less, and the network is also a prototype hardware developed. Integrated with this model, which you can. So the fundus camera is integrated with the retinal image. A small microcomputer, sort of computer Pi is that the Raspberry Pi and OS. It is having a Python, PyTorch, simulating anything it is. So what we have been done, we have also done with which is also available that we can so that it will be helpful in this case. And the display, and we have a simple keyboard and like we can also indicate, and we can just we have developed to see this one, and in this which you can use for which you can see here is a graphical user interface to helpful to get the output you can see. A study, this work is also patented. The similar type of experimental studies for your work. To the end of this have developed, almost all are. So, Imaging Scholar, we have worked with one of the retinal detachment lesions. Practitioner able to where actually the detachment is affected. So that also actually we have done in developed our own segmentation. Visualization, we have used the tools like to get image. So where actually the ophthalmologists will get the clear the retinal lesions, which have been used, and what framework is actually given. All these things which have been given, and also learn the paper. So that's what we can also able to do for you. This whole talk is that. So what we have been presented, it is start creating a data set in retinal detachment. So we have used the like and also subsets for classifying the retinal detachment disease. And not only for the the deep neural learning, but also we have we have discussed the different architectures. Importantly, in apart from the discussed how the graph time studies, and finally also we can use the segmentation algorithm get more landing in the particular to get more insights into the image. So these are all the outcome what we have all 6 years works which we have been done. And this acknowledgement project actually given the funding consecutive projects, DST, and another one is from all these outcomes. Our duty to acknowledge these are all my, the doctors, those who are helping, also the different to to help a unique algorithm, and also the help to share the, and of course we, and if you want to collaborate us, and you can also write any postdoc, or if you want to do any internship, also the whole contact is also available on my webpage, and you can feel free at any time. So we can, maybe tomorrow you may be my collaborator. And these are all the some of the references. And thank you. We are here actually, the Kartigai Deepam, and the homemakers are actually doing this Kartigai Deepam in this. Learn something, and for me, I want to deliver something. So gathered in this day. So happy Kartili. If you have any queries, I'm happy to answer.
Thank you, sir. Dear participants, if you have, kindly unmute yourself.
Good evening, sir.
Yeah, madam. Good evening.
University. So I'm research in IOM. So what is my question is in how we can protect the IOMT a different form of attacks in the domain of cyber security. Can you?
Your voice is interrupting. Someone is actually. Can you repeat your question?
My research is in the domain of with the combination of cyber attacks, or we have different types of intrusion detections are there. Man in the middle attack, and then DDoS attacks are there. So which attack are the most which we have to focus, and either we are deep learning or we can use hybrid model. So will you suggest?
Okay, to be very frank, actually, with this type of cyber attack, worked with this type of IOMT framework, especially what you have been described. And if you have any question be related to deep learning, so I can happy to answer.
Yeah. Okay.
Hello.
Thank you.
Yeah. Hello.
Yeah. Yes,
Yeah,
madam.
sir, you have shown in one of the slide transfer learning model. So, can this?
Yes, you can.
Okay.
You
Can you
can.
elaborate how you
Yes.
have used transfer
I'm
learning
coming
model?
to that point. I'm coming. See, we have initial time. We have only one thing, and now seeing EEG data, right? Yes. So EEG data for what you are going to use, madam? May I know?
Prediction of
No, if you look at, they're going to acquire the EEG, so
right.
which we need to have a different mechanism.
Yes,
And
yes.
mechanism, say for example, if you want to go for emotion detection, so you need to collect that.
Right.
Suppose if you
So
want to
I'm
like,
working specifically on epilepsy.
yes, and here the point is coming, it is that we have a well-defined data set for every burn. Actually accepted data, like it is a well defined. Other input is also I'm trying to data set which is also launched by IIT Delhi. So that is also publicly available in Professor Tapan Kumar Gandhi Delhi.
Okay.
So you have a number of data, especially for detection. Okay, what's the numbering mechanism? Then how we actually do the
No, the EEG
pattern.
signal for different humans. It is more on personalized level. So work on kind of prediction where one data set will be helpful for another set of people trying to do. So
Statement that may be your problem for your first question. Okay, so when you are going to detect the Caesar, while asking why can't transfer learning, it is depends on the data of number of data for Caesar. So instead of using a transfer learning, you can try to better model. So that will add novelty.
okay.
Good evening, sir.
Yes, madam.
Which used for GNNs, you identify.
Okay. No, again, if you look at the features, it depends on the data, but detachment data, all these, because the whole features in terms of the lesions, like talking about the lesions, so that we are taking into the all our studies, so we have the statistical features, then those features actually feed into the graph neural that will helpful to extract in the form of node, vertex.
So statistical features in the sense.
No, it is not. We have different, lesions. The lesions to date, cotton wool spots. There are different the features. It is the X feature for retinal image. Meter like, but this is the biological features.
Biological features.
It is quantitative and also it is qualitative.
Qualitative also.
Yes.
Available, sir.
It is available. I have shown quantitative data, and there are multiple imaging bank available.
Sir, and one more thing, this can be converted, embedded in a CT scan. I mean, convert and embed in a CT scan is there?
No, what device which you want to acquire, like from
No,
mobile or some other?
And I want to convert it into a CT scan and generate
It is not at all possible. Why we go for the CT? The CT machine is layer architecture. Like have a different layer with the layer one, acquiring the image from the image, main lobe, side lobe mechanism that will helpful to understand the different, parts and the lesions which is present in. And if you want to convert the image or if you want to translate from this, the originality of loss, then again what you want to do the image. But people are talking about this translation, but please, audience, please mute. And talking about image level translations, look at in terms of the transferred image. That is from my